The Wirth-Bore dot test is used to assess the degree of binocularity if no stereopsis is present. It can identify the presence of diplopia, a suppression scotoma, and the depth of suppression. This test can be done at both distance or near, at either 10 feet or 40 centimeters respectively. You will start by having the patient put on red-green anaglyph filters over their habitual correction with the red lens over the right eye. Leaving the room at normal illumination, hold the light with the green dots at the 3 o'clock and 9 o'clock position and the red and white dots at the 12 and 6 position. Then ask the patient, how many lights do you see? What color are the lights? And where are the lights located? After performing the test at 40 centimeters, repeat at 10 feet. Hi Mary, we're going to test your binocularity today. I'm going to let you put these glasses on over your contact lenses. Make sure you put the red lens over your right eye. Alright, great. And I'm going to show you some lights here, and I want you to tell me how many lights you see.
I see 4 lights.
Good. And can you tell me what colors they are?
I see 1 red and 3 green.
Good. And can you tell me where those lights are located?
There's 1 red light at the top and 2 greens on the side and 1 green at the bottom.
Perfect. Alright Mary, we're going to do the same test again. I just want you to put those glasses back on for me. Put the red lens over the right eye. Alright, good. And I want you to look back at my lights again and tell me how many lights you see.
I see 4 dots.
Good. And what colors are they?
I see 1 red one, 2 green, and 1 reddish green.
Perfect. And can you tell me where the lights are located?
The red one's at the top, the 2 greens are on the side, and the reddish green one's at the bottom.
Alright, great job.
Because the lights are against a dark background, the right eye with the red lens will see the red and white dots, while the left eye will see the green and white dots. If the patient sees all 4 dots, they are demonstrating a normal binocular response with no heterotropia. Alternatively, they may be showing harmonious, anomalous retinal correspondence if they present with an eye turn. The patient may see the white dot as being shimmery or an alternation of red and green. If the white dot is seen as green or as red only, it may indicate eye dominance.
If the patient sees 5 dots, ask on which side the red dots appear, the right or the left. If the red dots appear on the right, the patient is expressing uncrossed diplopia with esotropia. Uncrossed diplopia is experienced because a patient with esotropia will present with an eye turned in. This means in the deviating eye, the image of the target will hit the nasal portion of the retina, which will project an image to the patient's temporal field in visual space. If the red dots appear to the left, the patient is experiencing cross diplopia with exotropia. Cross diplopia is experienced because a patient with exotropia will present with an eye turned out. This means in the deviating eye, the image of the target will hit the temporal portion of the retina, which will project an image to the patient's nasal field in visual space. The eso or exodiplopia can then be neutralized using prism to help the patient regain fusion and get a response of 4 dots.
If the patient only sees 2 red dots, this indicates the patient is suppressing their left eye. In this case, the patient is only seeing the target with the eye behind the red lens, which is the right eye. If the patient only sees 3 green dots, they are suppressing their right eye. This response tells the examiner the patient is only seeing the target with the eye behind the green lens, which is the left eye.
To test the depth of suppression, the test can be repeated in dim illumination. Dim illumination will break suppression if the suppression is weak, but a deep suppression will be present in both dim and bright lighting. In order to test the size of a suppression scotoma, you would perform the test at both distance and near. We know a suppression scotoma present at near is larger than a suppression scotoma at distance because a target at 40 centimeters will subtend a larger retinal angle than a target at 10 feet. If a patient has a suppression scotoma at 40 centimeters, they are suppressing a larger portion of the retina than a patient who only shows a suppression scotoma at 10 feet.